right. So, in case you're absent today, today is Tuesday, the 17th, I think. uh, we're trying to solve inequalities, right? That have, like, there's an inequality, right? And it's a quadratic inequality. And I think this one, if you're following along in the book, I think it has a less than or equal to here. My program, I have a hard time finding a little symbol that has a little equal to bar on it. So, anyways, look, there's some algebra that we're able to do. And then realistically, like seeing a graph from me really helps out. Now, you can probably solve the whole thing by just graphically looking at it. And we're going to look at that in just a second. But I also want to review our algebra skills. And I'm going to ask you on the test to show some of these skills. So let's practice them. So let's look real quick here at a graph. Okay. And I'm going to attach this to our Google Classroom assignment, or at least put it in the stream. But we can see this parabola right here is above the x-axis. What does that mean, right? It means that all of the y values that are going to get generated by this function are all positive y values. We're all, coming up above the x-axis to graph the parabola. How could I change that? Well, I can make the parabola go higher in the y direction, but if I want some negative y values, I need to shift it vertically down, right? And so now I've got some negative values. Here I only have positive values. Here I only have negative values. Could I have, wait, did I just say that wrong? Here I have only positive values. Here I have some negative values. Could I make it all negative? Well, yeah, I could flip it over, right? I could make the A negative, and that makes all the y values negative now, right? And now I could move the parabola back up. Now some of them are positive and some are negative, right? So our goal, our task is to explain what x values generate, in this situation, less than or equal to 0 y values, okay? So let's look over here and let's generate some y values. The way that you would do that using a table is to, I call this the f function. So I want to jam into the f function a whole bunch of x values. And you can see some of the y values are negative, some are positive, right? Some are negative. Well, if we're going to explain to somebody what x values generate, let me look back again here, negative, right? This is saying less than 0. What x values generate negative y values? We need to explain all of them. We can't just say, well, at -3, -2, -1, somewhere between -1 and 0, it changes from negative to positive. We need to explain all x values that generate negative y values. Now, I'm just using this random kind of parabola here to kind of investigate the idea. It's not the same as this one right here. I could change it, and I will in just a second. I could change it and I could solve it using the graph. But that's not my goal right now. So let me click on a couple points here. And I'm just going to identify between what two x values is the function positive. Well, between -0.821 and 1.446. Outside of those two numbers, to the left of -0.821 and to the right of 1.446, we've got negative values. So let's just go ahead and change it so it's 1, -4, -12. All right, so I'm going to come up here. I'm going to make this one 1. I'm going to make this one -4. And I'm going to make this one 12. All right, so let me go back and double check. Oh, it was -12. I was going to say that's not generating two very interesting solutions. So I've got -2 over here, and I got +6 over here. And I want to tell people, look, all the ones that are between -2 and +6 are generating negative y values. See, here's -2. Oh, that's where it goes to 0. And then -1, it's a negative value. 0, it's a negative value. 1, it's a negative value. 2, it's a negative value, right? And I could keep coming down here and generating some more. And you can see at 6, it goes back to 0. And then at 7, it's +9. So graphically, let's just put the picture down here real quick. So we had a parabola that looked like this. Came down, came back up. And our x-intercepts are -2 and +6. And we want to explain the solution to this inequality is all x values that are greater than or equal to -2 and less than or equal to 6, because those generate negative y values, right? They generate negative y values. And we wanted this to be negative. That's what it's saying. We want this to be less than or equal to 0, or I guess 0. We took 0 as well, right? That's why I have little equal signs. So graphically, it's super easy to solve them. I hope you agree with me on that. Algebraically, it's a little bit more challenging. Like, we have to remember how to factor. So if I factor this guy, I put an x here and an x there because x times x gives me x squared. And then what two numbers multiplied together give me -12, but add together to give me -4. I think that would be -6 times +2, right? So -6 times +2 gives me -12. And like if I go the outsides, if I distribute the x times the 2, I get +2x. If I distribute the -6 times the x, I get -6x. So I got +2x minus 6x. Definitely gives me the middle term, right? So how does factoring help us out? Well, it helps us find when this quadratic is equal to 0. See, it's equal to 0 at 6 and at -2. It's telling us the two x-intercepts, of our graph. And that's an important part of a quadratic, right? This is a parabola when we graph it. So if we know what the x-intercepts are, right, like -2, and we also know that the parabola is going up because it's a +1 right here, right? So we know the parabola is going up. So at the far left, the parabola is decreasing. It hits an x-intercept. It hits this x-intercept right here. It keeps decreasing until it gets to its vertex. Then it starts increasing, and then it hits another x-intercept, right? And then it punches through and becomes positive. So these two x-intercepts tell us those transition points between negative numbers and positive numbers, or vice versa, right? So what I'm going to say is, from this information right here, and I know the parabola is going up, I know that it's going to hit at -2. Like, I could just in my head kind of make a little visual of this. I know it's an upward opening parabola, so it's going to hit at -2, and then it's going to hit at +6. And so that means that I want all the numbers between -2 and +6. So see how, like, even if I do this algebraically, it kind of comes back to a picture in my head or a graph that I put down on my paper. So I know I want all x values that are greater than or equal to -2, 2, and less than or equal to negative or +6. This is kind of the way I would do all of these problems, a combination of a little bit of algebra and a little bit of graphical knowledge, right? So let's look at this one right here. We've got a quadratic and we got a line. So we could graph these separately, this is the basic kind of parent function with the vertical stretch of 2, right? So I could come down here and I could graph the parent function, and I could, just make it look like a stretch by going something like this. At 1, we are up here at 2, right? So I've got my vertical stretch kind of demonstrated. And then I could graph x plus 10. So if that's 2, let's say this is 4, 6, 8, and then 10 would be like somewhere up here. Okay, so there's my y-intercept, and I got a slope of 1. So if I go down 2 over 2, boy, that'd be like this based on my scale. I've got a line that's going like this, okay? So I've just graphed my parabola, and I've graphed my line, and what I need to know is, when is the parabola below, that's what the little inequality sign means here, the line, right? So this is the line, and this is the parabola. So when is the parabola below the line? Well, it's in between wherever this x value is. We're going to report our answers as x values, and whatever this x value is. We want to know what, like, this x is. Let's call it x of 1, and this one x of 2. We're going to say it's in between these two values, okay? Now, how do we figure out those two intersection points? Well, it kind of comes back down to this. It comes back down to moving everything to the left side. So I'm going to go 2x squared minus x minus 10 is equal to 0. See, I want to know really when they're equal to each other, really. So I'm switching it to an equation like 2x squared equals x plus 10. But the only way really to solve this is to move everything to one side of the equation, to one side of the equation and use what's called the zero product property. In other words, factor it or use the quadratic formula, right? If we're trying to do this algebraically, right, and not just plug it into Desmos and click on the screen, which we're going to do in a second, we got to do some work like this, okay? So let's try to factor this guy. Well, it's got to have a 2x and it's got to have an x in order to generate a 2x squared over there. And now how do we generate a 10? Well, it'd be 2 times 5, right? 2 times 5, or it's 1 times 10. Now, I like the 2 and 5 better, just kind of thinking ahead a little bit, because if I take 2 times 2, so these two get multiplied together when we're distributing, right? And these two get multiplied together when we're distributing. So if I put the 5 right here, you see how I'd have a 4 and a 5? And if they subtract, they're going to give me a 1. Now, I've got to set it up correctly so I get a negative 1 right here. So I want the 5 to be negative, and the 4 part, the two terms that are generating the 4x, is a positive 4x. This is a negative 5x. That's a positive 4x. That gives me the middle term, right? So I've factored it. And now my zeros, this is how you find zeros. You set the factors equal to 0. So my zeros are negative 2. And then when they're more complicated, I write them out like this. I move the 5 to the other side, and I divide by 2. So I get 5 halves. My zeros are 5 halves and negative 2. So this guy over here, this x sub 1, is probably negative 2. And this one over here is probably 5 halves. Okay. So let's go to Desmos and we'll check it out here and see if we've got our answers. But before we do that, let's just kind of summarize what we just did. We want the numbers that are between these two, right? So I'm going to say x is greater than, and I want greater than only because we don't want it to be equal. So I'm going to say x is greater than negative 2 and less than 5 halves. If we wanted to know the other way, like when is the parabola above the line? So I'm going to switch that around a little bit. If the question was 2x squared is greater than x plus 10, then my answers would look like this. I would have x is less than negative 2. And I also want, so you'd have a union symbol, x is greater than 5 halves. Because I'd want everything out here and everything that way to keep the parabola above the line, right? So the parabola would be above the line over here. So this is like, how should I say this? Problem modified. So I've modified the problem down here to look at other situations. It's not always between one x-intercept or intersection point and the other intersection point. Sometimes it's on the left side of it and the right side of those two intersection points for our solution, okay? So let's look over here real quick at Desmos, and we're going to plug in 2x squared and x plus 10 on a new Desmos. I want to keep this Desmos kind of clean here. So I'm going to go 2x squared, right? 2x squared. And then on the next line, I'm going to do x plus 10, x plus 10. And I got to pull my graph down a little bit here so I can see it. Here's our negative 2 x value. We don't care about the y value so much. Yeah, their y values are both 8 there. But our question was, when is the parabola below the line? So the parabola is below the line between x value of negative 2 and an x value of 2.5. Okay? Now, look at this other option for just a second. Let's say we did 2x squared minus x plus 10. Like, I imagine moving everything to one side of the equation, like the x plus 10. If I moved it to the left side of the equation, now what I could do is, that's in green over there. I messed up. This needs to be a minus 10 right here. I'm saying, geez, that's not giving us any solutions. There we go. So this guy, notice, is at negative 2, and this guy is at 2.5. These are my x-intercepts for the parabola 2x squared minus x minus 10. See, we're really, when we solve this guy by moving everything to one side of the equation and setting equal to 0, we're really kind of adjusting a new parabola. Like it could be thought of as shifting it down a whole bunch. And now when we find these x-intercepts, we really are answering the question, when is the parabola below 0? It's kind of weird. Like you can solve the problem two different ways, right? You could say, when is the parabola, below the line? Or you can move the line over with the parabola, which is going to make kind of a new parabola, and you find when that parabola is below the x-axis. Whew, this is a lot conceptually. I don't think any part of the algebra is very difficult for you guys, but conceptually it's a lot to get our minds around. So be patient with yourself. Keep thinking about it, and I think it'll click. So thanks for your attention. Thanks for watching the video. If you were absent, good luck.